Hello dear students, once again welcome back to our channel. I am your maths teacher CG ma'am. In this video we are going to discuss about pair of linear equations in two variables. Two variables, okay, that is, what is a variable? Variable is usually we are using if we have any unknowns in our problems, isn't it? Okay, usually we are using small letters of English alphabet to representing a variable. Understood? And in this lesson we will use two variables. Usually we are taking A, B, or P, Q, or X, Y, or any letters of English alphabet you can use to denote the unknowns in the given equations. Okay, and what is equation? Equation is a statement of equality, or we will have LHS and RHS part. Okay, if an algebraic expression is equal to some quantity, then that expression is, we will say it is an algebraic equation or simply equation. Okay, and linear, what is the meaning of linear? The highest degree of the variable. Okay, that means the power in the variable must be 1, that is linear. Okay, and pair of linear equations. That means in this lesson we will make use of two linear equations in two variables. Okay, two means pair. Okay, and the only one condition is in both the equations we have to use the same variables. Pair means the pair of shoes, the same kind, isn't it? The same way. See, we have learned in the last year linear equations in two variables. Okay, that is 3x plus 2y equal to 6. Look children, here x, y, 3x plus 2y is equated to 6. So, it is an equation and I have used two variables x and y. Okay, so this is a linear equation in two variables. But what we need, we are discussing in this lesson pair of linear equations. Okay, so we have to write one more linear equation in two variables, then only it become pair. Understood that? What is the condition? We have to use the same variable, that is x and y. Okay, that is 4x minus 3y is equal to 1. See children, I have used the same variables x and y in the second equation. Okay, if you look into these equations separately, this is of the form ax plus by equal to c. Understood? That means here a is the coefficient of x, b is the coefficient of y, and c is the constant. And here see children, 4x minus 3y equal to 1. Understood? So, here 4 is the coefficient of x and minus 3 is the coefficient of y, and c, that is 1 is the constant. Okay, and the general form of pair of linear equations in two variables, that is a1x plus b1y plus c1 equal to 0. We will take this constant to LHS and we will make that RHS part into 0. Okay, that is the general form of linear equations in two variables, pair of linear equations. So, I am writing the second one. So, we have to represent the second linear equation with the same variable but different coefficient of x. Okay, usually, so A2 denotes the coefficient of x in the second equation. Okay, so A2x, but here don't write x1 because we have x and x1 both are different. Okay, so x and x, the same variables. Okay, so x plus b2y plus c2 is equal to 0. This is the general form of linear equations in two variables. Okay, see children, instead of 4x minus 3y equal to 1, if you are placing this 1 to this LHS, it will turn into this general form. So, that does not matter. So, minus 1 equal to 0. Okay, minus 6 equal to 0. Okay, but when we are solving this equation, we will keep this constant into RHS part. That's all. Yes, children, if we use instead of this x and y, p and q, that is 2q minus 7p equal to 3. These two are linear equations in two variables, but this is not a pair of linear equations in two variables. Why? Because in both equations you can see different variables. Okay, so in order to form pair of linear equations in two variables, the variables used in two equations must be the same. Then only we can say that pair of linear equations in two variables. That point is clear? Okay. Now we are moving to the solution of pair of linear equations in two variable. Solution. What is the meaning of solution? The value which satisfies the given equation. The values of the variables. Okay, that is x and y. Here the very important thing, that is, here you can see x and y in both equations. That means the solution of a pair of linear equation in two variable is nothing but those two values should satisfy in the given two equations, not only the first equations. Satisfy means if you substitute the values of x and y in the first equation, the LHS should be equal to the RHS. The same way, if you substitute the same values of x and y in the second equation, that equation must be satisfied. Then only those values x and y will say the solution of the pair of linear equations in two variables. That is very important. In the 9th standard, we have learned what is the solution of, or how many solutions a linear equation in two variable has. Okay, that means infinitely many values of x and y this linear equation in one variable will satisfy. Okay, that is if we have only 3x plus 2y equal to 6. That means for different values of x and y, you can make LHS equal to RHS. That is why we will say, or we can say, a linear equation in two variable has infinitely many solutions. That we have learned in the last year, and we have the solution set and we drawn the graph for the linear equations in two variable. Okay, infinitely many values are there, and we will see only two solutions, and between these two points you can draw a line, or you can say that the graph of linear equations in two variable always a straight line. Understood? But herein we are dealing with the pair of linear equations. That is, the values must satisfy by these two equations. Understood? Okay. And those two values are said to be the solutions of the given linear pair of linear equations in two variables. Okay, that concept is clear. That is about the solution of a pair of linear equations in two variables. Okay, and here comes a very important topic. That means you can see, after seeing the coefficients of this x and y and also the constants, you can say that which type of the solution it will have. Okay, that means by comparing the coefficients of x in both equations, y, that is b1 by b2, ratio, comparison, okay, the coefficients and the constants. That means you can say that which type of linear graph or the solution. Okay, that means here children, here a1 is coefficient of x in the first equation, that is 3. Okay, that is you take the ratio between a1 and a2. A2 is the coefficient of x in the second equation. Okay, that is a1 by a2 and b1 by b2 and c1 by c2. a1 by a2, b1 by b2 and c1 by c2. Okay, if a1 by a2 is not equal to b1 by b2, okay, that means here in this equation 3 by 4. 3 is the coefficient of x, that is a1 in place of a1. Here is 3. And in place of a2, here comes 4. That is coefficient of x in the second equation. And here b1 by b2. 2 by negative 3, that is 3, negative 2 by 3. If negative sign is there in the denominator, we will give that to the numerator or the whole fraction. So, negative 2 by 3. Okay, if both are unequal, is not equal to, that is if a1 by a2 not equal to b1 by b2, you can say that that pair of linear equations in two variable has unique solution. Unique solution means one and only one value for x and y. That equation will satisfy. But what we have learned the last year, see children, listen carefully, that is if linear equation in two variable, not pair, okay, will have infinitely many solutions. But what we have learned just now, okay, if we have pair of linear equations in two variable having a1 by a2 not equal to b1 by b2, in such cases, okay, that pair has one and only one value for x and y, or you can say that that type of linear equation, pair of linear equations in two variable has unique solution. If a1 by a2 not equal to b1 by b2, in that case the given pair of linear equation has unique solution. Understood? And this need not be always occur in the given equation. Okay, in some cases when you are comparing, you can see that, okay, that is a1 by a2 equal to b1 by b2. If this case, in this case, you have to find out that third ratio, that is constant, should be compared, that is c1 by c2. Or if that ratio is also same as b1 by b2, that is if this comes, if a1 by a2 equal to b1 by b2 and that is again equal to c1 by c2, you can say that those pairs, that is pair of linear equation having a1 by a2 equal to b1 by b2 and that is again equal to c1 by c2 has infinitely many solutions. Understood? Okay, and some cases a1 by a2 equal to b1 by b2 and that is not equal to c1 by c2. Okay, after getting a1 by a2 equal to b1 by b2, what do you have to say? You look into the third ratio. If that is equal to, again both are the same, it will have infinitely many solutions. If that the third ratio is differ from first and second, it will have no solutions. You cannot find the values of x and y which is satisfying by the two equations, first and second equations. Okay, then only it will become the solution, that I said already. Okay, these are the different types of in terms of solution of pair of linear equations in two variable. This is very, very important. Okay children, that is the first case is a1 by a2 not equal to b1 by b2. That is unique solution. Okay, solution. If a1 by a2 equal to b1 by b2 and that is equal to c1 by c2, infinitely many solution. Okay, infinitely many solution. Okay, and if a1 by a2 equal to b1 by b2 and that is not equal to c1 by c2, no solution. Okay, whenever you are having this pair of linear equations in two variables, whether you are doing a graphical method or algebraic method, you should have an idea what type of solution. Okay, that you can easily say by finding or comparing the ratios. See children, in the first and second case, that is for unique solution and for infinitely many solution, Okay, we will say this pair of linear equation in two variable is consistent. Consistent. Okay, that means it has solution, that is for some values that a pair of linear equations in two variable will satisfy. Okay, if it has no solution, we will say it is inconsistent, no solution. Okay, so how can we check whether the given pair is consistent or inconsistent? By checking their coefficient, by finding the ratios of their coefficients of x and y in both equations. Understood, children? Okay. See, another very important thing, that is, if you are solving this pair of linear equations in two variable by graphical method, okay, by graphical method, okay, if a1 by a2 is not equal to b1 by b2, okay, after plotting the graph, okay, that means we know that a linear equation in two variable is always a straight line. Okay, so we will have these two axes, okay, and after getting the solution set for the first linear equation in two variable, okay, suppose it is a straight line of this form. Okay, that is, this is a1x plus b1y plus c1 equal to 0. First linear equation in two variable. It's a straight line. And after drawing the second one, okay, what I said, if a1 by a2 is not equal to b1 by b2. Understood? Okay, that second line definitely intersect the first line when a1 by a2 is not equal to b1 by b2. Okay, that means in this manner, or any way it will definitely intersect. Okay, and the point of intersection, okay, that coordinates of point of intersection will give you that solution, that is x and y. I said for a1 by a2 not equal to b1 by b2, it has only unique solution, one and only one value of x and y. Okay, hence it is called unique. And in order to get that one, you just draw the perpendicular towards the x-axis and y-axis, or this point x coordinate and y coordinate. These are the values of x and y. Only for this x and for that y, this second is a2x plus b2y plus c2 equal to 0. Both equation will satisfy. This happens when a1 by a2 not equal to b1 by b2. That concept is clear, children. And in the second one, that is for a1 by a2 equal to b1 by b2, and that is also equal to c1 by c2. All these three ratios are the same. And that graph, okay, graph of that pair is always, if after drawing the first line, that is a1x plus b1y plus c1 equal to 0, and the second line, that second line is also will coincide the first line. Understood? Because it has infinitely many solutions. Understood? That means it will coincide the second equation after extending both the first and second, it will fall that, or it will coincide each other. Okay, this is when a1 by a2 equal to b1 by b2 equal to c1 by c2 for infinitely many solution. Okay, this is a unique solution and this is infinitely many solution. The graph will coincide each other. And the third case, what is the third case? a1 by a2 equal to b1 by b2 equal to c1 by c2 is not equal to c1 by c2. Okay, and in that case, after plotting the graph, okay, this is the graph of the first one. Okay, first line a1x plus b1 by plus c1 equal to 0, and the second line, see this, okay, both are parallel to each other, these two lines. That means no solution or inconsistent system. Okay, that means it has no solution, or the graph will be a parallel line. Okay, parallel lines. For a1 by a2 is not equal to b1 by b2, you can see they will intersect each other, the graph will intersect each other. And for the second case, infinitely many solutions, okay, coincide each other, and in the third case they are parallel to each other. This is all about the solution of a pair of linear equations in two variable in graphical method.